So let's consider 5x squared minus 11x plus 8 equals 0. We're going to use the quadratic formula to solve this. We see that solutions of ax squared plus bx plus c equals 0 are given by x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So you can Google the quadratic formula. You can hear lots of different quadratic formula songs. There's some to the tune of Pop Goes the Weasel. Okay, so is our equation in this form? Okay, well, we have some term with x squared first, and then we have a term with an x. Here's a term with an x, and then we have a constant. So yes. So let's figure out what each letter represents. Ax squared plus bx plus c equals 0. So a is the coefficient of x squared, so a is 5. B is the coefficient of x, so b is negative 11. And c is our constant, so c is 8. Now we're going to plug each piece into this equation. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's just highlight each piece. So a is 5, so we're going to put 5 in that place. B is negative 11. So I'm going to put a negative 11 just for B, and then right here. And then the C is 8. So we're going to plug this in. So x equals the negative of negative 11, excuse me, plus or minus the square root of negative 11 squared minus 4 times a, so 4 times 5 times c, and c is 8. All divided by 2 times a, or 2 times 5. So let's go through this and make sure we got it. So negative of negative 11, and then we have the negative 11 squared because we have b squared under there. A is 5, so here's my a, and then my c is 8. So take just a moment and make sure. Negative b plus or minus the square root of b squared minus 4 times a times c, all of it divided by 2a. Okay. So let's just start cleaning it up. Well, the negative of negative 11 is the same as just positive 11. Because you negate a negative, you get the opposite sign, you get a plus. Okay, so 11 plus or minus the square root. Well, negative 11 squared, be very, very, very careful here. Two things are being squared here, the 11 and the negative sign. So this turns into a positive 121. Now be very careful. Negative 11 squared is not the same thing as negative 11 squared. When you're writing this b squared under your root, make sure you put the whole thing in parentheses. This is negative of this, so negative 121. This is positive 121. They're not the same thing. Make sure you're very, 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 very careful and you use these parentheses right here. Okay? So then we have negative 4 times 5 times 8. So that is 160. Be very careful here. Check your sign. You have a negative times two positives. You're ending up with a negative 160. And all of it is divided by 2 times 5. Well, 2 times 5 is 10. Okay? So we have x equals 11 plus or minus the square root. So we have 121 minus 160. We're going to get a negative number. We get negative 39. All of that's over 10. Okay, well, we know already that that's not a real number. We have an imaginary number. Recall. The square root of negative 1 is defined to be I. So here we have the square root of negative 39. Well, we have a rule from algebra that says the square root of a times b is equal to the square root of a times the square root of b. So this can be rewritten as the square root of negative 1 times 39. But that is the same as the square root of negative 1 times the square root of 39. And then we see that this square root of negative 1 is equal to I right there. So we have x equals 11 plus or minus square root of 39 times I over 10. So there are two non-real solutions. The complex numbers are x equals 11 plus the square root of 39, I, and divide each piece by 10 if you wanted an a plus bi form, or x equals 11 minus, so we're going to do 11 over 10 minus square root of 39 over 10 times I. So these are both complex numbers. Okay. Let's do another example. I'll just fill it in right here. Let's see, let's also consider let's do 2x squared minus 3x minus 8 equals 0. And let's solve with the quadratic formula. Quadratic formula. So we're going to follow this pattern over here, but we're going to start fresh with different variables. So different constants rather, and coefficients. So a is the coefficient of x squared. So a is 2. And we see that b is the coefficient of x. So in this case, b is negative 3. And we see that c is the constant term, so c is negative 8. Then we fill in x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you are not familiar with this formula, I recommend that you write it down every single time you use it. And the more you write it down, the more problems you work, the more comfortable you're going to be, and you'll have this formula memorized in no time. So x equals the negative of negative 3 plus or minus the square root of negative 3 squared. Notice here again, just like over in this example, I'm putting parentheses because I want to square the 3 and the negative sign. Okay? Minus 4 times a times c. All of that is over 2 times a, or 2 times 2. So let's just color code this and make sure you can see what we're doing. There's your c. Your b was negative 3, so negative b. And then we have b squared. Okay, and then we have a is your 2. Everybody got it? So then we have the negative of negative 3. So x equals positive 3. Plus or minus, well in here we have negative 3 squared. So that's 3 squared and also the negative squared. So we end up with a positive 9. Now we have a 4 times a 2 times an 8 if you just look at the numbers. So 4 times 2 is 8. 8 times 8 is 64. Now let's check the signs. I have a negative times a positive. So overall the product here is a negative. And then multiplied by another negative, we end up with a plus. Okay. So we end up with x equals 3 plus or minus the square root of 73 over 4. So this one actually has real solutions. These are real solutions. We cannot break square root of 73 down further. Doesn't have any perfect square factors. So we're going to say this is x equals 3 plus the square root of 73, all of it divided by 4. Or x can be 3 minus the square root of 73, all of it divided by 4. And we see these are what we call irrational solutions. They're real numbers, but they're not integers and they're not rational numbers. Rational means fraction, remember?